to improve the licensing across regulators in Europe so that they share the same views and the same analysis on what is important in terms of safety. So I remain very prudent at this stage, but this is the effort we are trying to do. And we believe it's a way forward, at least to ensure a better collaboration at European level. And I can give you more detail on this if you want, but I think at this stage, that's where we are.
Thank you very much, Yves, for very much comprehensive comments. So now let me turn to Sama, and then I particularly want you to provide an overview of innovation which is taking place globally in terms of the nuclear, including which technologies different regions of the world is focusing on. So, Leon.
Thank you so much. And again, thank you for the opportunity to tell you a little bit about what's going on at a global level for advanced technologies. Of course, you know that right now, as we speak, more conventional Generation 3 nuclear large reactors are being built and deployed in many parts of the world, in North America, South America, in France, in the UK, in China, of course. So those are already not your old reactors that we have been operating for 50 plus years. But clearly, we are going beyond these large reactors that, as Yves said, are going to be very important. We are looking at small modular reactors, of course. And you know why, and I'm going to let John explain in much more detail what small modular reactors are going to be a game changer. I mean, the modularity, the simplification, the different business case, the affordability. So I will let John go through the details of that. But let me just tell you what is happening at a global level with these technologies. So for small modular reactors, let me start with those that use a coolant that is light water. It's essentially not very different from the ones that we are using right now in large scale. So we already have some of those operating. So you know that there is the academic Lomonosov in Pevek in Russia. It's already producing electricity and heat. We also have construction taking place in Argentina. And of course, there is many other demonstration projects that are happening as we speak, and we expect that are going to be successful before the end of this decade. So John will tell us about what is happening in NuScale, but there are some other like GE, Hitachi, etc., that are also moving forward with these reactors in North America and in Europe. So the other type of reactors that we are seeing is those that are high temperature gas-cooled reactors. This is also could be large and small, but I think that small modular reactors that are gas-based, gas-cooled are going to be very important because they can achieve higher temperatures, and as we discussed earlier, they could truly be a great opportunity to decarbonize sectors beyond electricity. I mean, we can do that also with light water-cooled reactors, but clearly the temperatures that we reach with high-temperature gas-cooled reactors are higher. So we see a lot of advance in those reactors. We already have one of these operating in China, the HTRPM, so this is already operating. And there is a lot of work moving forward very speedily in North America, in Canada, in the US. And also there is a few countries such as Japan, such as the United Kingdom, that have historically had a lot of experience with these gas-cooled reactors, and they are very much looking forward to continue to deploy them. So another technology that I will mention are molten salt reactors. This is another technology that is very innovative. It's based on science and technology that was developed perhaps in the 60s. However, now we have the opportunity to actually make these reactors a reality. There is still a little bit of effort needed. I mean, they won't be the first wave of deployment, but they will be shortly behind. So these reactors are using fluoride salts as the primary coolant, and in some cases they have a traditional solid fuel, whether they are fuel rods or fuel spheres. But in many cases, the fuel is actually dissolved in the salt, which is really a very, very innovative approach. So these types of reactors can be used for traditional small modular reactors, for micro reactors, but we are also seeing some developers that are looking into using this type of reactors to actually power ships. So the idea here is to help decarbonize the shipping industry, which, as you know, is a big source of greenhouse gas emissions, or also to put these reactors on barges, similar to what we have seen with the academic Lomonosov. So this is very important, and also this technology, this molten salt technology, could be very important as a heat storage opportunity. So again, just to diversify the opportunities as we link electricity and heat and hydrogen and other energy sources. So let me just finalize by telling you there is also reactors that are using this technology combined with, for example, liquid metals. So for example, we have the natrium reactor that, as you know, is a sodium cooled reactor, but has a molten salts to accumulate heat. And something that I like in particular to the very cool technology is that this is going to be deployed in Wyoming in the US as a way to repower coal power plants. So I think that is a great opportunity to make sure that the energy transition is all-inclusive and is equitable for also people that are working in other technologies. So let me also maybe finalize by telling you that these reactors could be done, small modular reactors up to maybe 300, could be teeny tiny micro reactors up to maybe 10, 20 megawatts. So really we can diversify the use of this technology and adjust it to the needs of the different users. And let me just finalize with something that is also happening, which is fusion. I mean, you know that we always used to say that nuclear fusion is always 30 years away. I really think that nuclear fusion is actually becoming much closer. Beyond the larger demonstration projects such as ITER that is taking place in Europe, of course, it's an international project with support of many countries in the world. We actually have a few startups that are coming with very innovative, very streamlined versions of fusion reactors that I really think are not so far away from true deployment. I mean, it still could be a decade or perhaps two, but it's not so far away anymore. So let me stop here.
Thank you very much, Sama. So now, let's turn to John. And now I want to provide you a short overview of the benefits which NuScale technology can bring about, and also when we can realistically expect the SMR deployment. So your comments is very much appreciated. Thank you.
Thank you. It's an honor to be here. I'm with NuScale. I don't know how familiar you are. We are a small modular reactor by definition. The unit itself is about 23 meters tall, including containment, a little over 4 meters wide. Each of the units generates 77 megawatts of electricity, and they're all separate from one another. So when I say separate, you could have a NuScale 4-pack, 6-pack, up to 12 modules, which essentially is 924 megawatts. We went through the nuclear regulatory process in the United States and got licensed in 2020. We're the only U.S. technology to date has been through the NRC licensing process, so we consider ourselves near-term deployable. I'm a technology provider. I'm not a constructor, I'm not a manufacturer, and I don't want to be. So we're heavily dependent on our supply chain. So our vision is we'll have a NuScale Europe, a NuScale Asia, and a NuScale Americas. If you look at our current supply chain, we're a publicly traded company now as of May, and a lot of that was because of our suppliers. If I look at, in Japan, we have Japan Bank of International Cooperation invested $110 million into NuScale. Why? Because JBEC would like to help finance NuScale projects around the world. IHI Manufacturing in Japan. JGC is an engineering procurement constructor in Japan. Then if you go to Korea, are investors and actually invested multiple millions of dollars, Samsung, Doosan, GS Energy, and these companies are looking at again for the opportunity to go global with NuScale. In the United States, 50% of our suppliers are from the US. And these are companies like BWXT, Honeywell, PAR Systems, all of them have a different function. And Baker Hughes has recently come on. These are major suppliers, major investors. So when I left COP26, I had 4 walkaways. Everybody was talking about hydrogen. Everybody here is talking about hydrogen. So what do you have to do to scale up hydrogen? You need about 200 to 300 metric tons a day at a price point, let's say below $1.50 per kilogram. That's what it's going to take. And I'm a believer now, because there's so much focus on hydrogen, it's going to happen. And this week, Secretary Kerry, who's the special envoy to the Biden administration for climate change, and the energy minister of Urenco announced that NuScale and our suppliers are going to assist Ukraine in a major infrastructure redevelopment, and a big piece is energy for hydrogen production and ammonia production. That's huge. And we are already in a consortium I cannot announce right now, but hydrogen's going to happen. The other benefit for NuScale that we had to prove to the Nuclear Regulatory Commission, we're a conventional light water reactor. Our fuel source is less than 5%. It's available around the world. That's what 400 reactors use in the United States. So we have available fuel. Our components in our unit is pretty much off the shelf. Each unit has a dedicated turbine generator. So that allows us to scale up these projects. So if I come to an area like Egypt that are looking at cities of the future, so Egypt could essentially come and put 2, as population density increases, they can put 2 modules in, then they can go to 4 modules up to 12 modules. So other countries that are looking, like if you look at Cape Town, South Africa, a population of about 4 million people, they have no water. They are running out of water. So the other big one is the utilization of energy from small modular reactors for reverse osmosis desalination. Water, as you know, is huge right now, and this is for advanced communities. Like I said, I'm really bullish on all technology being successful. Most of the analysis that you read and how big the market is really oriented to electricity. But if you look at the applications, as I just mentioned, direct air capture sequestration, desalination, hydrogen production, ammonia, it's big market. And so we'll all come to market at different times, but the market potential for advanced nuclear. And the other thing I'd like to say, I was first at COP21 during the Obama administration with Secretary Ernie Moniz. Seeing from what happened to COP21 to 26 to 27, more and more people are becoming much more pragmatic, recognizing renewables are needed, advanced nuclear are going to be needed. If we're going to really meet 2 things, climate disruption and energy security. And as you know, energy security right now, particularly in Central Eastern Europe and also everywhere on the world, it's companies and countries are revisiting advanced nuclear. Thank you.
Thank you very much, John. And using prerogative of the chairperson, I'd like to also touch upon a little bit about Japan situation, because as you know, since Fukushima nuclear accident, Japanese energy policy has been very much preoccupied with somehow the anti-nuclear fundamentalism, renewable fundamentalism. That kind of debate has been very much distorting Japanese energy policy making. But facing with power supply demand crisis nowadays, and also energy crisis caused by Ukraine war, Japanese government is giving fresh look at nuclear options. And up until now, the government has simply said we are going to restart nuclear power plant, of which safety has been confirmed by Nuclear Regulatory Authority, and no word about construction. But strangely, Japanese government has been also spending money for research and development of new nuclear technologies, such as SMR or advanced reactors or fast reactors or the high temperature gas-cooled reactor or fusion with some roadmap. But unless there is a clear vision that if these technologies go well and that technology could be deployed in the market, then who will invest in that kind of technology? So in that sense, it is very encouraging that our Prime Minister Kishida said in Green Transformation Council in August, saying that first we need to accelerate the restarting of nuclear power plant, 17 all nuclear reactors. Second, we need to maximize the use of existing nuclear power plants on the premise of ensuring safety and perhaps even beyond 60 years. Then third, development of construction of new next generation innovative reactors incorporating new safety mechanism. So this is a very much remarkable announcement. Of course, we need to do a lot to overcome various, say, bottlenecks, but it is a good signal to nuclear industries. And talking about SMR, as you said, John, JGC and IHI is, say, actively engaged in the new scale technologies and SMR technologies, and we have a very much high expectation that SMR could be deployed not only in Japan and the US, but also in the third countries. So that could expand the market for SMR. So with that, now let's turn to the panel discussion. And first of all, we are talking about the decarbonization, not only in power sector, but also more broader sectors. So very much generic question, but in the ideal world, what do you believe would be the best energy system in terms of decarbonizing as many sectors as possible? So perhaps, if you can start.
So I think we somehow already touch on this matter. There is, we believe that we have to reason on system and not one technology by technology, as has been the case in many places. So I think we can not allow silos anymore. And at the end of the day, we need everything. We need renewables, we need nuclear, we need all forms of nuclear, as many as possible, because the challenge is massive, as I've shown in the figures. There are so many needs in different hard-to-abate sectors. We have not talked about desalination, but I think it's one of those countries where Egypt, desalination is something that will also be needed. And we all need all of that without emitting any carbon. So no room for gas, no room for obviously oil or other fuels. We need full decarbonization, only decarbonized solution. So I think on that, the objective is pretty clear. We have to, as I was saying, we need all the nuclear technologies. We have not mentioned, for example, micro reactors, but those technologies could also make sense in some application. We need different forms of SMRs, advanced reactors, AMRs, and probably for some time we'll still need large reactors because there is so massive needs, and there is no more time also for complacency or delays. I'm afraid on that. We've been listening too many times that we are going to develop nuclear, yes, one day. But I think if, for example, one example I have in mind, I was traveling to Poland in 29, I think it was, and they were about to launch a nuclear program at that time. So now they have apparently started to really go into the concrete, but I think on that we've lost 13 years. And within those 13 years, they would already have some plants running, and this is the change. It would change the perspective already. So I think we really have to accelerate, and there is a competition, I know, between vendors and all of that, but I believe there is room for everyone. That's my feeling.
Okay, thank you very much, Yves. And inclusiveness is a keyword, I think. We need to use all the available options, including nuclear and also renewables and so on, which we are aiming at is decarbonization. So we should not be too much picky and choosy about particular technologies. But how about you, Sama? What is your perspective?
Well, I was going to say that the energy systems of the future won't look anything like what we are familiar with. So we are looking at electricity systems. We may be looking at hydrogen. We have mobility that is also being electrified, and then we have heating and cooling. We have heat for industrial applications. So I think that we are going to see a lot of coupling among all these different systems, and it is going to be important to figure out how to make sure that there is enough power and energy, not just electricity, but energy to integrate all these other things. So in that sense, I of course think that nuclear energy will be a key component of that integrated energy system. Obviously, as we already heard, it's not going to be the only one. We are going to have many other different energy sources included in there. And of course, as far as nuclear, I think we are going to see large, small, very small, traditional, very advanced. So I think that we are going to have a space for everything. And then I would say one more thing, and I think it's important because we are today at COP27 that is taking place in Africa. And we need to recognize that in many countries, in the greater north in particular, we are very much focused on decarbonizing, which is obviously a huge priority. This is why we are here. But let's not forget that there are many other countries that perhaps have different priorities and different timelines than what we have in the bigger north. Because if you are looking at the energy transition in Africa, for example, we are talking about a transition that is going to go from no energy to energy. That is a different transition, and this is an urgent transition. They are not looking to decarbonize in 2050. They are looking to energize in 2030. So this means that perhaps the priorities are going to be different, and the choices that they are going to make may be also different.
Thank you, Sama, touching upon that very much important issue, because we tend to talk too much about mitigation only, but adaptation is also very much important, and also the shape of energy transition is very much different between developed and developing countries. And as you rightly pointed out, in Africa, there are so many people who do not have access to modern type of energy, and we cannot simply say they should use renewable from tomorrow. And there could be many options, and including, say, fossil fuels in some times. But anyway, so John, what do you think about the energy system issues?
I think Sam has said it spot on. First of all, I need to stress, for advanced nuclear really to get started, the government support by countries is critically important. The U.S. government has been extremely supportive of NuScale getting to where we are today. They also have advanced reactor programs looking at the next wave. It could be molten salt or sodium fast reactor, as Sama said, or it could be a pebble bed. So there's a lot of emphasis and focus within our government to get these nuclears deployed. But Africa is a very good example in terms of sub-Saharan Africa. I've been to Zambia. We just recently did, thankful to our government again, an introduction into the country of Ghana. We've been talking to Ghana for 5 years. And to the professor's point about going to places in Africa where you see produce in the fields rotting because they have no refrigeration or electricity for refrigeration to get it out of the fields. Another area of the world where water is going to be critically important. And one thing I do say about the NuScale reactor I like, we had to prove to the NRC that we, for safety reasons, do not have to be connected to a grid. So every other reactor has to be connected to grid for safety. So when you think about that, we could be deployed as distributive generation right up next to an end user or right near a community, let's say, or a city, that we could provide if because these units are scalable, I could take 3 of them to provide electricity and 3 more provide for hydrogen or desalinization. So that's where I think the interest is really, people are starting to really peel the onion back on advanced. The other thing we need, I look at the industry in itself, we have technologies, we have the capacity to execute, but financing and funding in countries is critically important. Where does the money come from? What's the regulatory framework look like? You know, in the US, we have Exim now has a quorum, and they've been very supportive. The DFC, we also recently with the European Green Taxonomy, very important for nuclear. And then with the United States, the Inflation Reduction Act, it doesn't necessarily impact me directly, but it does my customers. And it could reduce their costs of clean energy up to 30% through investment tax credits and production tax credits. So the movement is moving, and I see it across the globe.
Thank you much, John. And you touched upon very much important point, government support and government policies, because the power sector in developed countries are increasingly liberalized. And under that situation, maybe that could be a bit challenging for power industries to make a huge investment for nuclear. So, and then recently, Inflation Reduction Act was adopted in the Congress, and it has certain incentives or subsidies for nuclear as well. So, Sama, what do you think about the necessary policy environment for new technology deployment?
Well, I think that it is absolutely essential. So policymakers need to put in place policies that are technology neutral, that are going to be able to recognize the attributes of all the low carbon energy sources. So that is going to be essential. Number one, because it's going to create this environment of trust and visibility. So, and that is going to incentivize, for example, investment, which is something very essential. Another thing that I would say that is beyond the traditional policies is markets. I mean, unfortunately, we are right now seeing firsthand, because of this energy crisis that we are facing in Europe, that the energy markets are very dysfunctional. They currently do not work. They haven't really worked for a while, but now it's patently obvious to many of us that it's not working. So number one, we need to redesign or readjust these markets in a way that they recognize, as I said, the attributes of all low carbon energy sources. We need to redesign them in a way that they value things such as energy independence, energy security, stability, reliability, 24/7 generation. But also, we need to build in these markets things like signals that are going to incentivize long-term planning. We cannot just make decisions based on tomorrow's price. We need to be able to plan for the next 10, 20 more years, as you very well know. Energy policy cannot be a 4-year decision, a 2-year decision. So, and of course, once that we can make these long-term planning decisions, that is also going to help, once again, to bring with us the finance community. Now they are going to have transparency, visibility on how these investments are going to be sustainable. They are going to be profitable in the longer term. And then, very related to finance, which is something that I'm sure Eve will want to touch in more detail, is making sure that when we are putting in place, and this is of course policymakers, when we are putting in place criteria, whether it is taxonomies for deciding which technologies are or aren't sustainable, when we are putting in place standards to disclose and explain how we are producing the different energy, those policies, those taxonomies need to be, once again, technology agnostic and based on scientific criteria. So, because that is going to help us be able to make the right decisions. So I'll stop here because I know that John and Eve probably have very other good stuff.
Yes. Eve, so then what is the current situation about taxonomy?
So it's an excellent question, and I have the experts just in front of me, but maybe she will want to say also something. So taxonomy, I think this is a well-known good news across the world that eventually the European Commission decided to include nuclear as a sustainable source of electricity of energy. I think it's a good step forward. Even if we know there is a lot of flaws in the current policy framework, maybe not detail much on that, but there are some constraints that are put which are unrealistic today. But I can touch on that if you want. I think what is important also, it's a step forward in the right direction, but it's not the end of the journey, not at all. Because now we need to see at European level in particular many other files to be adapted to this, I would say, new way of viewing things, I would say. To be, as an example, simple example, today nuclear is excluded from the Just Transition Fund. So Just Transition Fund is the fund which it's eligible for coal region in order to get rid of coal. And today nuclear is excluded from this. Only renewables are eligible. I think this is one typical example of a file where a fund we need to see a lot of change, and I can quote many others. So I think it's really a good step forward, and I think it's something we are going to build on in order to push the Commission back on this logic, saying, okay, now we have to reconsider many of the existing European framework, but a good step forward, clearly.
I see. Okay, thank you very much. And concerning taxonomy, can I understand that European Commission has decided to include nuclear in taxonomy, and that taxonomy needs to be finalized by the consent from European Parliament or European Council?
It's done. It was done in July. I think on that we can affirm that we have good news. Thanks to particular Jessica, who's been instrumental in that respect. But,
I see. Okay. So now, we have talked a lot about SMR, and SMR is clearly a very much, promising technology. So I'd like to ask your opinion about how we consider the coexistence between large-scale reactors and small-scale reactors. What could be the possible combination?
Well, I could just give it. By the way, I agree that the European taxonomy is not the end all, but it's certainly a step in the right direction. Secondly, I was on a panel here a couple days ago with an executive from World Bank, and it's inconceivable for me that the World Bank has not realized yet, with the parts of the world that they're focused on, that they don't see the advantages of SMRs, and particularly when you ask them why. The only nuclear power plant the World Bank's ever financed was in Italy in like 1958. And to me, that's, looking at the parts of the world that they have their focus on, they really need to reconsider and peel the onion back, as we say, on looking at developing countries and the aspirational issues. Secondly, I'd like to say, when I speak to individuals in government representation from Kenya, Ghana, there's one aspect that people don't generally talk about, and that is you have countries that are highly dependent upon fossil fuels. That's where the jobs are. And so to segue those workers over from coal and refurbish those power plants that often are in the United States or in remote communities, renewables don't offer that many jobs. And they will tell you, advanced nuclear can, in fact, to go into an existing, let's say, 300 megawatt power plant, many of those people are the same people we need in advanced nuclear to run that plant. You need electricians, you need pipe fitters, you need maintenance, you need security, you need many of these people, and there's this perception everybody has to be a degreed nuclear. That's not true. I only need 8 degrees to run my plant for a 300 megawatt, and 5 of those are 2-year degrees. So, and the other thing, labor is critically important. We are working very closely in the United States with the North American building trades. And what we're doing with them is working on training modules to go into existing communities where utilities are allowing us to have access to their human resources of these are the people and skill sets we have in this plant. How many of those people can you in fact train? And it's the majority. These people do not want to have to move from their communities that they've lived in their entire life and go to somewhere else with lesser paying jobs. So we've got to figure it out.
So do you think that U.S. government could exercise its influence to the matter of financial institutions so that they could finance nuclear technologies as well?
Yes.
Oh, so let's do that. Okay,
No,
so Sama,
let
what do
me
you
just
think?
let's
Yeah.
amplify the message that John just had because this is essential. So the finance community, I mean, we all know that large low carbon infrastructure in energy, in clean energy, it is high capital. This is nuclear for sure, but this is also renewables. This is also many other things. So the importance of the finance community, the multilateral banks, particularly when we are trying to finance newcomer countries and low and middle income countries, it is essential. These countries need to have access to affordable financing because this affordable financing is going to determine the cost of the project and the final cost per kilowatt hour of the energy that is going to be produced. So that's a job that we definitely need to do. But let me answer the original question that you had asked about whether large and small. So I'm going to go back with what Yves had said, and he mentioned this at the European level, and I'm going to amplify the picture at a global level. So if we are serious about decarbonizing the entire economy, it's not just electricity, but it is everything else that we discussed, heating and cooling, industry, shipping, transport, etc., etc. We are going to need lots of energy. The enormity and the urgency of this task is incredible. So there has been several studies, and I'm talking about reputable studies done by very serious organizations such as the IPCC, the UN Economic Commission for Europe, etc. Many of these studies quantify that we are going to need about more than 1,200 gigawatts of nuclear capacity installed in 2050 if we are to keep up with all this low carbon energy demand that we are going to need. This is huge. I mean, if you do the math, we are talking about building probably 50 gigawatts of new nuclear generation every year from now until 2050. And this is going to be large reactors, small reactors, micro reactors, conventional reactors, advanced reactors. It's going to be all of them. So I truly believe that this is a huge market in which all these technologies are going to have a very important role to play. Some of them will be deployed very quickly, and we urgently need them to be deployed very quickly, no pressure. And some of them will be deployed a little bit later, but they are all going to be essential.
Okay, so Yves, what do you think about the coexistence between small and large-scale reactors? How they could interact?
So I think we somehow we were already commented on that, but I think it's a question of time to market first. As I said before, we need urgently new capacities, new nuclear capacities, new renewable capacities. But unfortunately, today the timeline is much too long. There are some promises to have new SMRs, for example, in the early 30s or even before. But I would say the deployment should be massive and the needs are urgent. When I see, for example, some projects in Europe today where to have some promises to have new capacities available in 2035, this is much too far away. And there also this sense of urgency also is if we want to be, if wants to be considered as a solution, it has to be it has to deliver its promise as well. We cannot say, okay, we're going to be there. We cannot convince the broader public as we somehow did today in Europe. I think on that the mindset is changing in the positive way. When we are only able to say, okay, we are going to implement new build, but not before 2035, 37. This is not an acceptable answer because we owe to the public, we owe to the citizen some solutions, and we cannot promise a solution without being able to deliver them.
Very good answer. Thank you very much. So now let's open the floor, and I'd like to take several questions from the floor. Yes, could you please identify yourself and then go to the question? Thank you.
Hi, thank you. Shirley Rodriguez from Generation Atomic. So I was listening to a podcast a few days ago, and it says that large water reactors business is a technology without business, and the SMRs are a business without the technology. What are your thoughts about that? And I would like to add it without technology, but also without policies and regulations.
Okay, who'd like to answer? Okay, John.
I just like that. That's a good example. You know, I can remember going to IAEA conferences, and then a few years ago, it would say small is now the large. But a good example what's going on right now is Poland. The gentleman mentioned Poland. The Polish government wants gigawatt-sized large reactors. They also, our customer, KGHM, it's a process company. They want SMRs. What do they want SMRs for? They want process heat, they want electricity, they want to have somebody next to the end user. So there's an example where both big and small complement one another. And I suspect around the world we're going to see there's countries that are going to need large-scale reactors. You know, Baraka is a great success story at UAE. Baraka UAE is now also looking through ENEC possible of SMRs. Why? For cities of the future, for desal, things that I mentioned earlier. So there's going to be, the needs are a little different, but I don't see large-scale reactors going away.
I would agree. I mean, as I said before, there are occasions in which large reactors are going to be essential. So we talked about the example of UAE. It's happening in Egypt as we speak. They do need lots of energy. And I would suspect that many countries, not only in Africa, but in Europe, in Southeast Asia, in South America, they need much more than 300 megawatts. But it depends on the application. I mean, as John said, if you have a situation where that is the right choice, it would be chosen. When you need something bigger, you have something bigger. But I mean, large reactors are being built today. So I think that what you said is a good soundbite, but I don't know that it adjusts to the reality. No, it's not. It wasn't yours. I know that certainly. But whoever said that sounds good, but maybe not so real.
Yeah, Yves.
So all in all, I agreed with the previous speakers. Maybe I would give a also political angle to that, because I think particularly for large reactors, it's true also for SMRs, we'll need a very clear political will, support, affirmation. This goes through also some capacities to mobilize financing, support financially developers or companies. So we'll need the framework. And I think the issue today, for example, in Europe, is this support doesn't exist. And we've been struggling as an industry to get the framework, incentivization that we need to get there. The amounts, particularly for large reactors, are massive. We need to mobilize a lot of money. There are a lot of, the payback period is relatively long. But after 20, 30 years, it's money making. It's money machine, it produces 24/7. It's obviously the best solution, and we see this for long-term operation. So I think this initial trigger is needed, and we have struggled in the recent past to get it. I hope is going to change. I can see some good signals.
So thank you. Now let's take another question. Any question? Yes.
Didier Oyon from EDF. I attended a lot of panels just outside the Atom for Climate pavilion, and I've never heard about Atom actually. So, and it's a pity. But do you get some insight, because Kadri Simpson was talking a lot about renewables and so on. But if we don't back up, I mean, nuclear with some European commissioner and so on, we are going to be in trouble. So taxonomy went through, passed in July, and good. I understand that you were a key a key player in it. But what do you have from inside? Do you think that it's just, I would say, something for the public, or is there a real support to nuclear, or are we waiting? Are we going to wait a lot?
Is there any support from the Commission on nuclear? Response is no. To be very honest, so there was a very positive speech from Commissioner Simpson on Friday in Prague at the European Nuclear Energy Forum. So I think this was the first, I would say, the more positive ever speech I've heard. But I don't have 50 years experience of commissioners, but at least for the last 10 years, that's absolutely clear. So it shows that we, as I was saying, may see light sometime at some point of time. But beyond the speech, we need to see now what are the concrete actions. And then that, I'm not very optimistic for now. The issue is always the same in Europe. European Commission cannot act if they don't have some formal consensus. And fortunately, we still have German, Austria, Luxembourg axis, which is very strongly anti-nuclear. They don't want to hear anything that would be positive on nuclear from the commissioners. And we are stuck with that today. What is the good, I would say, positive on that is we see more and more countries which become more and more vocal, outspoken on nuclear. And I think on that the Commission stands out to realize that they have to do something. But we are still at the very infancy of any new policy, I'm afraid.
So in the European context, I think what matters is not the European Commission itself, but the policy by individual countries which have chosen nuclear options.
Yeah,
because in the European Commission level, they cannot cope with anti-nuclear countries. So.
In theory, each country is free to choose its mix.
Yeah.
In theory.
Okay. So, Osama, any additional comments about the question?
No. I mean, I was just going to maybe add that we do see lots of countries, not only in Europe. I mean, in Europe, if you look at Poland, it has what, 84% approval for nuclear. Czech Republic, 70-something%. Netherlands, I can't remember, but it's pretty high. UK, same thing. So in Europe, we see a lot of countries that are trying to move forward with nuclear, but even though they can make national decisions, as Yves said, there is a European Commission for something, and some European policies could be, if not paralyzing, certainly very slowdown, a significant slowdown. But at a global level, I will tell you that we see lots of interest. In Africa, for sure, I mean, John already mentioned several countries that are very interested. I mean, Ghana, of course, Nigeria, Kenya, obviously Egypt. I mean, so there is many countries in Africa, in South America, Central America, Southeast Asia. So things are happening, but as we said, it is necessary to have bold, pragmatic, realistic governments that put in place pragmatic policies, not just blah, blah, blah policies. I mean, there is very few countries today that have energy policies. Think about this. Most countries have climate policies. This is completely different. A climate policy is a laundry list of wishes. We will decarbonize, we will do this, we will do that. And energy policies is something different. These are the things that we are going to do to get there. And there are very few of those, unfortunately.
Sama, thank you very much. A very good summary. And I think, unfortunately, it is coming to the end of this session, but I very much enjoyed the discussion, and we could talk a bit longer. But to summarize, I think the various new technologies, most notably SMR, and also advanced reactors, and also the high temperature gas-cooled reactors, and so on. So there is a growing interest in new nuclear technologies, given the nuclear's contribution to energy security and also climate mitigation. And that interest has been intensified under the ongoing challenges caused by Ukraine war. And that interest is not only in developed countries, but also in developing countries. But in order to make these technologies to be deployed, the credible and also pragmatic and also foreseeable government policies, it's indispensable, including various incentives, and also financial environment is quite important. So I'm very much encouraged that US might work hard to change the financing policies of the World Bank or ADB or AFDB. So please give our message to Special Envoy Kelly, okay? So thank you very much. So with that, I think it is time to conclude this session. And please give thunderous applause to all the panelists. Thank you very much indeed. Thank you.
Thank you.
Thank you.
Thank you very much. The recording will be made available, so you will have it. So
Thank you very much.
thank you very much for doing. We have also invited you to dinner this evening.
We have to go out.
You have to go out.
Yeah.
Okay, no problem.
Thank you very much.
No problem. Thank you. Maybe see you tomorrow.
See you tomorrow.